Do the reviews today. First thing I want to do, yesterday we talked about chapter 1. Is there anything you want to talk about chapter 1? Is there any questions if you guys did the review? Is there anything on chapter 1 you want me to go over? Otherwise, to me, chapter 1 is kind of a done deal. Not that I won't answer any questions tomorrow or Monday on chapter 1, but if there's anything on chapter 1 you want me to go over, now would be a good time. How many of you got chapter 2 kind of done last night? Couple? Okay. All right, let's do this then. Chapter 2. The first 4 sections is just simply solving equations. It's really all it was. And the first, it was baby step getting there. We did 1-step equations. X plus 7 equals 12. Solve for x. 4x equals 12. Solve for x. The hard ones were 2/3 x equals 12. How do you do the first one? Minus 7. Divide by 4. How do you solve that one? Multiply by reciprocal. So I'd multiply by 3/2, which I would do it as 12 divided by 2 is 6 times 3, 18 is the answer. Okay? The only other, if you're looking at, everybody look at page 80. So if you look at page 80, again, these are just 1-step equations with addition and subtraction. That was section 1. The whole section was just, if it says plus, you minus. If it says minus, you plus. Yes, there's positive, negatives. Yes, there's fractions. Yes, there's decimals. But fairly easy. Okay, then section 2, if you look at page 87, same thing. 1-step equations, but now it's just multiplication and division. Yes, there's fractions. Sometimes it's x over 5 equals 10. Well, how do you get rid of it? Divide by 5? You multiply by 5. Sometimes there's fractions on one side. Sometimes there's fractions on both sides. It could be 2/3 x, but instead of equals 12, it could be 10/7. Well, again, do it the same way. Multiply by the reciprocal. And now you just multiply across. You could cross reduce. So now you got what? 15/7 would be your answer. Easy enough. After doing the 1-step equations, what was next? We did 2 or multi-step equations. So now all of a sudden you had some slightly longer ones. The harder ones were ones that look like this. 9 equals 6 minus the quantity of x plus 7. What do you think the mistake people make here is? What's the first thing you'd probably want to do? Distribute that negative. So that's the same thing as 9 equals 6 minus x minus 7, right? That's the mistake people would make right there. And then, you could move them over individually, or you could say 6 minus 7 is -1. Now add the 1. And if negative x equals 10, then x equals -10, right? So now you're at multi-step. There's distributing in there. Basically everybody look at page 96. You still have fractions in there. You have combining like terms like number 14, where you have multiple y's. You have a 2y and a 5y. You got to combine those. To me, I think the first 3 sections of this chapter are pretty easy. Anything on that page you would like me to do? You guys seem to be doing pretty good with this stuff. Okay. And then the next section, section 4, was the only difference between this question and section 3 and then section 4 is you might have now x's on both sides. So what's the first goal if you have x's on both sides? Now you got to get all the x's on one side, right? So after, if that, once I distributed here and got to this point, how would that have changed what I did next? Now I'd say, well, now I'm going to add the x over here, and I might minus the 9 to get the 9 over here now. So now I have all the x's on one side. Now I have all the numbers on the other side, so I have a 6 minus a 7 would be -1, -1 minus 9 would be -10, and then I would divide the 3, and x would equal -10/3. Are we good with those? Everything in the first part of this chapter. Can you also check your answers? How can you check your answers? Plug it back in. And remember what I said, do we always check our answers? Should we? Yes. Do we always? No. Do I always double check my measurements when I'm building something? No. When is it really important to double and triple check your measurements? When you want it, when you want to make sure it's perfect, right? You know, for example, last weekend I made myself a little shelf to hold my power drills, whatever. It was just something quick and raw and putting together in my own barn. Do I care if it's a little cockeyed? Not really, as long as it does the job. I'm also in the process of paying Mr. Schran, who's a really good woodworker, to build some new vanities because we're renovating our bathroom. I didn't really bother to double and triple check my measurements because it's just for my barn. Who cares if it's a little sloppy? If I'm paying him a lot of money to make really nice cabinetry, basically, for my bathroom, he better double and triple check because now it's, for somebody else. Now there's money involved, right? Now there's, well, you have an exam coming up. To me, that's now important. Like, that's the time to really make sure you double and triple check. Check your answers, plug them back in, take that extra 5 seconds it takes to see if it's the right answer, because now it's real valuable. Now it's that exam time, right? So, to me, that's the time to really make sure you're checking your answers to make sure they make sense. Also, weird things happen. When you have x's on both sides, sometimes. When you distribute here, what's going to happen? When I subtract 7x to get them all on one side, uh-oh, what just happened? All the x's go away, right? When all the x's do go away, what's the answer? When all the x's go away, the answer is either no solution or all real numbers. Is this a no solution or all real numbers?
No solution.
Why?
Because 4 doesn't equal 7.
Because 4 doesn't equal 7, right? That's an incorrect statement. 4 is never going to equal 7. So that's no solution. What would it look like if it's all real numbers?
7 equals 7.
It'll say 7 equals 7, or 4 equals 4, or 5 equals 5. It will be a true statement. So at that point, it's either all or nothing. So don't forget about those. Are we good with basically the first half of this chapter? It's just solving equations. Okay. Everybody take a look at page 109. This is the section that I'm most worried about for you guys. This is the section that caused most of the problems for people in this chapter. This is where you took something like 5x, y divided by z equals 12, some random equation, and I said solve it for x, or I said solve it for y, or solve it for z, where we should be able to take that equation. Let's do it 3 different ways. Let's take that equation and I'll say solve it for x. And this actually could be 3 separate questions. This could be question 10, 11, and 12 on the exam, all right next to each other. I'll give you this. In question 10, I'll say solve that for x. So what's the first thing you do to get the x by itself? I would butterfly it basically, get rid of that z there. So now I have 5xy equals 12z. Now what else do I need to get rid of? I need to get rid of the 5, I need to get rid of the y. So x is going to equal 12z divided by 5y. And that is what that answer would be. Or question 11 might say solve for y. And then to me it would be basically the same process, where I would butterfly it, right? And I get to 5xy equals 12z. And then, how do I get the y by itself? Divide by the 5 and divide by the x. So that would be y would equal. Or I'll say solve it for z. And again, first step, I would probably butterfly that. And I'd get to the point where it says 5xy equals 12z. Now how do I get the z by itself? Just divide by 12. So it'd be 5xy divided by 12 would equal z. We need to be able to take any equation that has multiple variables and solve it for whatever variable they tell us to solve for. Okay? Like this is a very, very useful skill. Those you can pretty much guarantee you're going to have some of those on the exam. Okay, Abby? Any questions on those? If you're looking at page 109, is there anything on page 109? You know, if you look at any of those equations, whether it be 4, 5, 6, 7, you look at those and go, all right, how would I get the A by itself? How would I get the B by itself? How would I get the C by itself? And don't just do it like the book, like number 7. If you're looking at number 7, that one says solve for A. Well, make sure you can also solve it for the B. Make sure you can also solve it for the C, because that could also be the same idea. Okay? Anything you want me to do. Remember, if there's ever the variable in the denominator, like number 7, isn't the variable in the denominator? At some point, you're going to get it to here, and you're going to butterfly it. Like number 7, what does that say? B plus C is equal to 10 over A. Well, great. How do I get the A out of there? Butterfly it. That's the same thing as A times the B plus C equals 10. And yes, you could distribute, but I don't want to distribute because I want to get the A by itself. If I distribute, aren't I going to have two A's? I don't want two A's. I only want one. So what's another way I could get rid of that times BC? You could divide it by the BC, B plus C. And now I have the A by itself. Okay, so are we good with those? And guys, I can guarantee you there's going to be a couple of those. Make sure you know how to do those. That, to me, was the worst section of this chapter, whole chapter. Now, we're not done with this chapter. That's actually only halfway through. So the first half of the chapter was just simply solving equations, and then take an expression like this, equation like this, and just solve for whatever variables. Just basically solving equations. Section 6. If you look at page 117, you guys are good at these. Oops. Butterflies, right? 8x equals 20. X equals 28. Reduce the fraction. Easy? Just basic butterfly ones. Be careful though, what do you have to do with number 15? So that one says 3 over 14 equals s minus 2 over 21. You have to remember to distribute. So when you butterfly, you got to have 14s minus 28 equals, what was that, 63? And then add the 28 and divide by 4. Okay? You guys seem to be pretty good at those kinds of things. And also, everybody look at page 124. I actually is a couple of these as well, where they're going to get a similar diagram, and you have to set it up. What is to what as what is to what? So if you look at like 2 and 3, or 6 and 7, how would you set up those proportions? Like 5 is to what as 7 is to what? What's an easy way to do those if you're a little confused by the drawing of what side goes with what? Look up at this where it says triangle ABC goes with triangle DEF. Well, the 5 is the what? AB? What goes with AB? DE. So the 5 has to go with the 4. So I go 5 is to 4 as, and then the 7 is between what two letters? A and C? Well, great. What goes with A and C? D and F? Great. Where's D and F? D and F is X. You get it set up, butterfly. So use that statement, okay? Are we good with those? Percents. Everybody look at page 130. Most of you guys like the method. Remember, this section we spent a lot of time doing things different ways. Most people like the percent over 100 equals is over of. Yep, there's going to be some of those on there. You can set it up as proportion, or you can put it as a decimal and do the multiplication method as well. So I don't care if you do decimal methods. Like number 2, you could either use the percent over 100 is over of, or you could just multiply. Of means multiply, right? 40 times 0.75. That'll get you both answers. So be careful with those. but there will be some of those on the test as well. Okay, flip over to page 141. Percent change. Percent increase, percent decrease. How do you always find the percent change? You find the change, and you always divide that by what? The original or the new? The original. So if I say Home Depot buys a power drill, buys it for $40, turns around and sells it for $100. What's the percent markup? Well, what's the change? How much did it change by? Changed by 60, right? So you went 100 minus 40 is 60, and you always divide it by the original, which would be 40. So now you grab your calculator, and 60 divided by 40 says 1.5, which means it's a what percent change? 150% change. Make sense? And that would be an increase. Does it change if it's a decrease? I bought my car for $10,000. That's what I bought it for. Right now, I can only sell the thing for $7,000 because depreciation, my wife ran over a mailbox, whatever. How do you find percent change? So, what would I divide? Nope. What always goes on top? The change. How much did it change? $3,000. It went down by $3,000. Now what am I going to divide that by? Is it the 10 or the 7? The 10. Because it's always the original. So I would do the change, $3,000. I lost $3,000. Divide that by $10,000. It's 7.3. Which means that's a percent decrease. All right? It's always the change divided by the original. How much did it change? Always divide by the original. And then the only other ones are increase it by a percentage. So like number 28. Everybody look at number 28 on page 141. Find the result when 24 is increased by 75%. There's two ways you can do it. You can multiply by 0.75, find the increase, and then add it, right? That's the two-step approach. What's the one-step approach? What could I just multiply it by? If it's increasing by 75%, what percent do I now have? 175%. So I could just multiply by 1.75. Number 30. Now let's do 31. If it's decreased by 5%, you could multiply it by 0.05 and then subtract it. Or if it's decreased by 5%, what percent do I still have? If you walk into a store and it says 5% off, what percent are you still paying for? The other 95. So just multiply by 0.95 and there's your answer. Okay? That's chapter 2. That's all chapter 2. We're done with chapter 2. For those of you that have kind of started the chapter 2 review, or the chapter 2 test assignment thing, any questions that you want me to go over on those? Anything at all? Okay, this weekend, you have a couple jobs. Number 1, if you haven't finished chapter 1, do that. If you haven't finished chapter 2, do that. I would also try to have chapter 3 done by Monday because that'll help. You'll already know what questions you need to ask on Monday for chapter 3. Try to have those done. When are your, this is second hour, if your second hour exam, when are these review assignments due? Wednesday. If you're in my 6th hour, it's not going to be due till Friday. But for you guys are second hour, it's Wednesday. Okay? And you're going to turn them in with your exam. That's the same as for the virtual kids too. If we do have a snow day on Monday, which I don't think we're gonna, but just throwing it out there, it's Friday, just prepare. If it happens, I'll try to make a video over chapter 3 for you. Probably won't be very long. Just so you know this is what to expect, okay? And I'll try to communicate with you through Remind and say, hey, there's videos uploaded. Find 15 minutes to watch a video. Work on your exam reviews. I would take your book home this weekend either way to make sure you can work on your review assignments. And the exams are on Wednesday, okay? And then same thing on Tuesday. I mean, I think the probability of us having 2 snow days next week is slim to none. But if it happens, today's the last review day. I'll have a video for you for chapter 3 and chapter 4. Exams on Wednesday, okay? And remember, especially on days like that, I'll communicate everything through Remind. Say, hey, the video's here. Do this, do that. All right? That's all I got.